Okay, so here we're trying to figure out this sum. Okay. Now, later on, when we study a little bit of counting and probability, and a little bit of other stuff, we're going to learn that people have studied these sums. And mathematicians have figured out that this sum is n times n plus 1 times 2n plus 1 all over 6 for any n. And one of the things we can do is just check for a few that it's true. Okay, so what value of n do you already know this sum?
Well, we know
it's a 10.
You know it for 10? Okay.
No, actually. We know it for
1.
1.
1?
When n
Okay.
is 1.
Alright, when n is 1, what's the sum?
So
1.
So then we could test the equation.
Okay.
N
It's
1
times 2 times 3 all over 6.
Does that equal 1?
Yes.
Yeah.
Alright.
6 over 6.
Okay, what's another value of n for which you know the sum?
How about for 2?
Okay.
2.
Can you tell me what it is for
Well,
2?
it's 4 plus 1 is 5.
Alright, and let's see what we get when we plug in 2 for n here.
So let's see, 2 times 2 plus 1, 3, so 6, and plus 2 and plus 1, that would be 5.
Okay.
So that would be 60 over 6. 60 over 6. Well, it's n, which is 2.
Yeah.
Then n plus 1 times is 6. And
Yeah.
then 6 times 5 is 30. Then
Yeah.
over 6 is 5.
Just like we thought,
Yeah.
right? Okay, now so for 10, what we were summing up before was going to be 10
10
times 11 times,
21.
so we get 10 times 11 times 21
over
all over 6.
Nothing's divisible by 6 here, but we could cancel a 2
Okay,
and a 3 from the 21.
alright, so I cancel a 2 there to get a 5, cancel a 3 there to get a 7, and what am I left with?
Well, you get
35 times 11.
35 times 11.
Which is 350 plus 35.
so it's 385.
Okay, so 385. Okay, good. Can you hear the eraser?
Okay.
And we can start to see what's going on for some large numbers here. Let me ask you, what do you notice about this product when n gets really large?
Well, this is gonna look a lot like when n gets really large, these plus ones won't matter much.
Okay.
So it's gonna look like n times 2n over 6. So that's 3n. I mean, n cubed. N cubed over 3.
Why n cubed over 3?
Well, because you can cancel a 2 here to get a 3.
Ah,
So
And
you
then you have n cubed.
n cubed over 3. What does that remind you of?
Well,
That reminds me of, it's 1/3 of a cube of length n.
Wait a minute. Is that what we were seeing?
Yeah.
Yeah.
Can you believe that?
Whoa.
So here's some small pyramids like we had before. These are our 3D printed ones. And can we zoom in on them? Where's the camera? Not quite. I don't know if it can focus on it.
Might
Let's
have to
see.
take a picture of it.
That's all right. But these have lots of squares, right?
Yeah.
Do they have infinitely many?
No.
No.
No, but can you put these together to form a cube, do you think?
Yeah.
Yep.
Okay, go
They're
ahead.
just like our zone tool ones.
Give it a try.
Let's see. So there it is.
So when you have infinitely many, or not quite infinitely many,
But a lot.
but a lot, you start getting an approximation that really looks like a cube. And the error in that volume is really small.
Yeah.
Yeah.
Isn't
It's
that
smaller
amazing?
and smaller.
Isn't that amazing?
Yeah.
So it's just from adding squares together.
Just,
So it's an amazing connection between algebra and geometry.
Yeah.
Yep.
That's number one. And now here's an interesting secret.
What?
Okay, in 2 dimensions, for a triangle, we saw the formula was base times height divided by 2.
Yeah.
In 3 dimensions, for a pyramid, we saw the formula was base times height divided by 3.
Maybe in 4 dimensions it's base times height over 4.
Huh. What do you think it'll be in 10 dimensions?
Base times height over 10.
Maybe it's base times height over n, where n is the dimension you're in.
That would be interesting to
Yeah.
see.
Yeah.
I wonder if we could figure out how to do that experiment.
Except for
We can't go into. I don't think we have anything from the 4th dimension.
we don't
around
have any.
here.
We can't do the 0th dimension because that would be undefined.
Yeah. Well, but it's interesting actually. In 1 dimension, a length is just the length divided by 1.
Which is
So.
just a length.
So it's an interesting conundrum.
Yeah,
Maybe we can figure that out.
maybe.
All right. So, fun project.
Yeah.
You like that?
Yeah.
Yeah.
Feel like you know a little bit more about pyramids?
Yeah.
All right. Cool. Thanks, guys. Good work this morning.